Hi, 9. This is the video for 3B, 9B enlargements. An enlargement is a transformation that just affects the size of your shape. So it can either make it bigger or smaller because it changes the dimensions. So two important things that you need to complete an enlargement. One is the scale factor, so I'll talk about that in a sec. And then one is the center of enlargement. We'll go through that in a sec as well. Okay, so the main thing for a scale factor is how much you're increasing it by. Okay, so how many times bigger is something? That's all a scale factor means. So this scale factor is positive, and it is a whole number, so it's an integer. So we can expect this shape to get bigger. So our object is going to get bigger. If this was a fraction, for example, a fraction less than 1 but bigger than 0, our object would get smaller. Okay, we're not going to go through that today, but just for a little bit of context. So this scale factor of 2, that means that each of our side lengths is going to be 2 times bigger now. So we have a side length here of 1, so 2 times bigger. Just draw this anywhere, it doesn't matter because we don't have a centre of enlargement. That's going to be 2. Okay, we have a side length here of 2, so times 2, that's going to be 4. 2 again, that's going to be 4. Oops. And 1 up here, that means that's going to be 2. Okay, so we can have different scale factors. This time we have a scale factor of 3, so because this is a whole number bigger than 1, we can expect our object to get bigger. Okay, so in this one, because our scale factor is 3, it's going to get 3 times bigger. So we go up 2 on this side. So 3 times 2, that is going to be 6. So let me just make sure I've got room. 1, 2, 3, 4, 5, and 6. Okay. Then this side length is going to be quite tricky, so we'll just leave that for now. So we've got 1, 2, and 3. Okay, so we can count along easily. That's definitely 3 squares long. So if we times that by 3, we end up with 9. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we just join those together, we should be able to see that this shape here is 3 times bigger than this shape. So we've enlarged our object by a scale factor of 3. When we're doing these enlargements, we will be creating a similar shape. So a similar shape is a shape that is the same in the same in the angles but has different dimensions. So this side length is different to this side length. However, these 2 angles here are the same. Same with these 2 angles here, and our side lengths are different. Okay, so this angle here is the same as that one. This angle here is the same as that one. This angle here is the same as that one, but our side lengths in each of these shapes are different. Okay, so they are similar. In this example, you can see that we have an enlargement, so we need to enlarge this shape by a scale factor of 2, where P is the centre of enlargement. Okay, so we know what a scale factor of 2 means. That just means that we're going to make it 2 times as big. And now we have our centre of enlargement. So this is the second bit that we needed to complete our enlargement, okay, to describe an enlargement. So scale factors, nice and easy. We'll deal with that in a sec. The centre of enlargement, so P is our centre of enlargement. That is already on for us, okay? So what this means is, unlike the first example where we just drew the image anywhere, as long as it was 2 times bigger, we need to enlarge from our centre of enlargement. So we start at our centre of enlargement and we project lines out through each of the corners of our object. Okay, so from the centre of enlargement, project out. From the centre of enlargement, project out. Okay, so what we can see here is we have our lines going through. So we should be able to see that from this corner, we've gone 1 to there. Okay, so we just pop in marks for 2 further away, okay? So from our centre of enlargement to here, 2 further away, that's going to be there, okay? So we've gone 1 that way, so it's going to be 2 this way, okay? So to this corner here, we've gone 1, 2, so 2 further away than that, that is going to be 4. 1, 2, 3, 4. Okay, a little bit trickier on the diagonals. So we start there and we just measure. Is the easiest way. Okay, so that's there, and then 2 further away. That's going to be here. Okay, and much like this one, measure. So there's that halfway, and then so it's going to be that one there. Okay, with this method, you always want to check that your dimensions work. So do the dimensions work on this one? Let's have a look. So we've gone 2 up, this one we've gone 4 up, and we are enlarging by 2, by a scale factor 2, so that's right. We've got 2 across, and that one's 1 across, so we've half enlarged by a scale factor of 2. So I'm not a massive fan of the projection lines, so the method that I usually use is just counting squares. So we started our centre of enlargement, we then count how many squares we go up, so how many squares we go up in the x direction, and how many squares we go up or down in the y direction. We don't have x's and y's in this one, so how many do we move left and right, and how many do we move up and down? Okay, so if we move up 1 from our centre of enlargement to this first corner, our scale factor tells us to do 2 times that, so we do 1, 2. Okay, we then count to our next corner, so 1, 2. That's going to be 4, so 2 times 4, and 2 times 2 is 4, so 1, 2, 3, and 4 away. And then we need to look at how do we get to this corner from our centre of enlargement. So we go 1 up in the x direction, so we go 1 to the right, and then 1, 2 up. So we've gone 1 and 2 up. 2 times that, so we do 1, 2, 1, 2, 3, 4. So we times both directions by 2. So that was 1, so we times it by 2, that gives you 1, 2. Then we've gone up by 2, so 2 times 2, that's 1, 2, 3, 4. Okay, and exactly the same with this corner here. So we've got 1, 2, right, and 1, 2 up. So that's nice and easy. So 4 in both directions. 1, 2, 3, 4. 1, 2, 3, and 4. Okay, join them up, and you might want to check again. So if we join those up, we will find that we have 4 up, that one's 2 up, so that's 2 times bigger, that's perfect. And then we've got 2 across, that's 1 across, and the side lengths are the same on that side, so that's perfect. Okay. So in this question, it asks you to describe this transformation, okay? So we can see that this shape to this one, so let's say from A to B. Okay, so that was just part of the question. Describe the transformation from A to B. We need to decide what our scale factor is. And what our centre of enlargement is. Okay, so we can see there's been a change in size. So we know that this is going to be an enlargement, and these are the 2 things that we need for an enlargement. Okay, so we can see that we've gone along 1 in this one, and we've gone along 3 in this one. So what have we done to get from there to there? We've done 1 multiplied by 3 to get to 3. Okay, we then have 2 up and 1, 2, 3, 4, 5, 6 up. So 2 and 6. So we know that we've done 2 multiplied by 3 to get to 6. Okay, another way of thinking about that is, so the side length of image, so that's the one after the transformation, divided by the side length of object. Okay, so that's just asking how many times bigger is your object, your image than your object. How many times bigger or smaller? Okay. So side length of the image, that was 6 for this one, and side length of the object, that was 2 for this one. So our scale factor has to be 3. So 6 divided by 2 is 3. Okay. Centre of enlargement, we need to use our projection lines is the easiest way to do this one. So what we need to do is match up the corners from this shape to the corresponding corners of this one. So this corner here was enlarged from this one. So we're going to join them together. Okay, so just going to draw that in. Okay, like so. We are then going to join up our next corners. So this is enlarged from this corner here. So not quite lined up. There we go. It's better. And then this last corner here. Sorry, these two last corners are matched up with these two here. Okay, so our centre of enlargement has to be where all of these lines meet. Okay, so that's going to be at 1, 2. So 1 in the X, so we've gone along 1 and up 2. So that's 1, 2. Okay, and that is your enlargement. So that is your transformation described. Okay, so that's an enlargement. That's an enlargement of scale factor 3 and centre of enlargement 1, 2. This last question, you will find that we have a scale factor of 2 and using the centre of enlargement 0, 1. Okay, so that centre of enlargement is what we're going to start with. So we haven't marked that on here yet, so let's pop that on. So we go 0 along in the X direction and 1 up in the Y, so that is here. So this one's a little bit unusual because we don't usually have our centre of enlargement in the middle of our shapes. So with this one, what we could do is either projection lines or just counting the squares. I'll go through both of them, okay? It works the same way, despite the fact that our centre of enlargement is in the middle of our square, our shape, sorry. So we start our centre of enlargement and we just project out through all of the corners of our shape. Okay. So we start at this corner, we started our centre of enlargement and we just see how many we've gone through to get to that one. So we've gone 1 and 2, so 1 and 2. So that's where that corner is going to go. So it's 2 times bigger, okay? Doubling this distance, 1, then 2, and doubling it here, 1 and 2. Start here, 1, 2, and 1, 2. So that's going to go there. Doubling this distance, 1, 2, and so 1, 2, 3, and 4. Okay. Like so. Okay. If you want to do it with counting the squares, you still have to mark on your centre of enlargement. So the centre of enlargement was 0, 1, so that's still there. And then to each of these corners, we need to count how many squares we have to go. So to get to this one, you go up 1 in the Y and down 2 in the Y, and the X, sorry. So go up 2 in the Y and across, so down by 4 in the Y. Okay, so that's 1, 2. So we go 2, 4. Okay. So we start here and we count up 1 and in the Y and up 2 in the X. So we go up 2 in the Y now and up 4 in the X. We count down 1 in the Y this time and across up 2 in the X. So we go down 2 in the Y and up 2 and up 4 in the X. Down 1 in the Y and down 2 in the X. So we go down 2 in the Y and down 4 in the X. Okay, So we join up our corners. Either of these methods are fine. They will give you the same answer. Okay. What I would do after you've joined them all together is check that you have in fact drawn the correct shape. Okay. So with this one, you've got 2 on this side length. This one is 1, 2, 3, 4. So we've got 4. So yes, that is 2 times bigger for our scale factor. And then we've got 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4. So that one here is 4 times bigger than this one, so that's perfect. And that is the same in these cases. Well, I've got 2 there, 4 there, 4 there, and 8 there. Okay, so everything is 2 times bigger. So both of those methods are fine. Try either way and have a go at the exercise.